Hello Year 3 and welcome to week 3 of our fractions learning. You're doing a brilliant job so far. I am very, very impressed. Last week with Miss Lopez we were learning about equivalent fractions. These are fractions that have different numerators and denominators but they're the same size, they're equal. Here I've got two pieces of paper that are the same size. I'm going to fold one of those pieces of paper in half. I'm going to fold it into two equal pieces. And here I've got one of the two pieces, one half. I'm going to fold this other piece of paper into quarters, into four equal pieces. And I'm going to take one of those four pieces. I'm going to take 1/4. Now I can see that 1/4 and 1/2 are not equal. They're not the same size. This means they are not equivalent fractions. But if I take two of my four pieces, 2/4, I can see it is the same size. So I know 1/2 is equivalent, the same as 2/4. And I could keep going. I could fold my quarters into 8 equal pieces, into 8ths. And now I can see that 1, 2, 3, 4 8ths is equivalent to, is the same as 1/2. And you could keep going again and again, folding smaller and smaller to find all the equivalent fractions. But we would say that 1/2 is the simplest form of the fraction. Today we're going to be comparing fractions. We're going to be looking at two fractions to see if they are equal or if one is greater than the other or less than the other. I'm really excited to see all your learning, and remember, if there's anything you're confused about or any questions you've got, make sure you send Miss Downing or Miss Lopez a message. Let's get started. Today we are going to be comparing unit fractions. Let's start by reminding ourselves of the vocabulary we have already learnt to help us describe fractions. We have learnt two very important words, denominator and numerator. Can you pause the video and remind yourself what is the meaning of these words? The denominator is the total number of equal parts a whole has been divided into, and this goes on the bottom of our fraction. The numerator tells us the number of equal parts we are counting. And in a unit fraction, the numerator will always be 1. Let's have a look at an example. Here I have a shape that has been divided into 4 equal parts. So my denominator will be 4. One of those parts is shaded. So that's the part I'm counting. So my numerator will be 1. 1 out of 4 parts. This is the fraction. Do you know how we would say this fraction? Correct, we would say 1/4 or 1/4. You'll notice that the numerator is 1. We call fractions with a numerator of 1 unit fractions. So this is a unit fraction. Today we're going to be comparing unit fractions. So we will also need some vocabulary to help us compare. Do you know what it means to compare? Pause the video and see if you can remember. When we compare, we take two or more amounts and we look to see which is greater, which is smaller, or if any are the same. So we will need to know the words greater than, less than, and equal. On the screen are the symbols that we have used before to represent these different words. Let's start today's lesson where we will be comparing unit fractions. Comparing fractions with a numerator of 1. For today's lesson, you will need 2 circles of paper that are the same size. If you don't have 2 circles, you can use 2 squares of paper, but remember they must be the same size. Here are 2 of our friends from Maths No Problem, Sam and Ruby. Sam and Ruby each have a paper circle of the same size, just like you should have in front of you, or paper squares of the same size. Sam cuts his circle into 2 equal parts and keeps 1 part. Ruby cuts her circle into 4 equal parts and keeps 1 part. Who keeps a bigger part, Sam or Ruby? Can you help solve this problem by looking at the picture and using the pieces of paper you have in front of you? You can cut, fold, or write on the paper to help you. Pause the video and see if you can work out who is going to keep a bigger part. Let's have a look together. Sam cut his circle into 2 equal parts. So you can see on the screen I've used a dotted line to divide the circle into 2 equal parts. Ruby cut her circle into 4 equal parts. Can you put your finger on the screen and count the equal parts with me? 1, 2, 3, 4. Well done. Both Ruby and Sam each keep 1 part of their circle. Here is 1 part of Sam's circle and 1 part of Ruby's circle after they have cut them up. Who keeps a bigger part? Correct! We can see that Sam's part is greater than Ruby's. It's bigger. We might use this symbol here to show that. We would say Sam's part is greater than Ruby's part. Can you say that with me? Sam's part is greater than Ruby's part. We used our pieces of paper to show who kept a bigger part. Our friend from Maths No Problem thinks that she could solve the problem using a bar model. Is she correct? Do you think this is possible? Can you pause the video and have a go at drawing the bar models to show this problem? What do you think they would look like? Let's have a look together. We know that Sam cut the circle into 2 equal parts and kept 1 part. So instead of having a circle, this time I've got a bar, and Sam cut it into 2 equal parts. So just like we folded our circle, I'm going to do the same to the bar. I can see now there are 2 equal parts. Sam kept 1 of those 2 equal parts, so I'm going to shade 1 of the parts. Do you know how we would show this as a fraction? I would like you to pause the video and draw Sam's bar, and next to it write the fraction that he kept. Think about the denominator, how many equal parts his bar is split into, and the numerator, how many of those parts we are counting. Pause the video and write down the fraction. kept 1/2 of his bar. He kept one of the two equal pieces. Let's have a look now at Ruby's bar. Here is a bar to represent Ruby's circle. Ruby cut her circle into 4 equal parts. So I'm going to split the bar into 4 equal parts. Ruby kept one of those parts. So I'm going to shade one of my parts. Can you pause the video and draw Ruby's bar underneath Sam's? Then have a go at writing the fraction of the bar that Ruby kept. Ruby kept 1/4 of the bar. She kept 1 out of the 4 pieces. Now we have 2 bars to show Sam's part of the circle that he kept and Ruby's part of the circle. Sam kept 1/2 of the circle and Ruby kept 1/4 of the circle. We were trying to prove who kept a bigger part, Sam or Ruby. Now we know the fractions for the parts they kept. We can ask ourselves, which is greater, 1/2 or 1/4? Pause the video and see if you can explain which fraction is greater, 1/2 or 1/4. We can see that 1/2 is greater than 1/4. Can you say that with me? 1/2 is greater than 1/4. If we wanted to write this using our symbols, this is the symbol that we would use. And again, we read this by saying 1/2 is greater than 1/4. Now it's your turn to have a go at a question. I have got 2 fractions here, and we are trying to work out which is greater, which is bigger. To start with, I'm going to look at the denominators because this will tell me how many equal parts I need to split my bar into. The first one is 1/4. How many equal parts do you think I should split my bar into? Correct, I need to split it into 4 equal parts. The next fraction is 1/5. How many parts do you think I need to split my bar into? Correct, I need to split it into 5 equal parts. You will notice that the bars are the same length. When we're comparing fractions, we need to make sure we draw our bars so that they are the same length, just like Ruby and Sam's circles were the same size. Pause the video and see if you can explain which fraction is greater. Let's have a look together. If we want to shade 1/4 of the bar, we need to colour in 1 of the 4 pieces. If we want to shade 1/5 of the bar, we need to shade 1 of the 5 pieces. Can you see which fraction is greater? Correct. 1/4 is greater than 1/5. If I wanted to write that using my symbols, it would look like this. And we would say 1/4 is greater than 1/5. Here are 3 more questions for you to have a go at on your own. I would like you to draw out the bars, make sure they're the same size, and think about how many parts you need to split the bar into and how many of those parts you need to shade. Then choose the correct symbol to compare the fractions. pause the video and have a go. Let's have a look at the first one together. Here we are comparing 1/2 and 1/10. We're comparing two unit fractions. I'm going to start by drawing a bar and splitting it into two equal pieces. This will help me show 1/2. Then I need to draw another bar and it needs to be the same length, but this time I'm going to split it into 10 pieces because the denominator is 10. When I'm shading 1/2, I need one of those two pieces. So the top bar now shows me 1/2. If I'm going to shade 1/10, I need to look at one of those 10 pieces. So the bottom bar now shows 1/10. Can you tell me which fraction is greater? Correct, we can see that 1/2 is greater than 1/10. So this is the symbol that we would choose. Can you read it with me? 1/2 is greater than 1/10. Well done. I have noticed that when we're looking at unit fractions, that means fractions with a numerator of 1, when we look at those types of fractions, the greater the denominator, the smaller the fraction. Do you agree with me that when the fraction is a unit fraction, the greater the denominator, the smaller the fraction? Let's see if we are correct. We are going to compare two unit fractions, two fractions with a numerator of 1. 1/3 and 1/2. If we are correct, then 1/3 should be the smaller fraction because the denominator is greater. 3 is greater than 2, so the fraction 1/3 should be smaller. So we would say 1/3 is less than 1/2. Let's see if we can prove that we are correct. I've got one bar that I've split into two equal parts to represent 1/2. I've got another bar that's the same size that I have split into 3 equal parts. This will help me show 1/3. I'm going to shade one of the parts. I can see that we were correct. 1/3 is the smaller fraction. So we know the greater the denominator, the smaller the fraction. Now it's time for our independent practice. Today I would like you to do pages 105 and 106 in your workbook. Remember what we learnt today, that when the fraction is a unit fraction, the greater the denominator, the smaller the fraction. Good luck, Year 3, and I will see you tomorrow when we will be comparing more fractions.